3, 2, 1, top. Allumage et décollage de...
The LISA Pathfinder mission is opening up the possibility of the first space-based gravitational wave detector. After its launch, the spacecraft travelled to its operational orbit 1.5 million kilometres from Earth. And since early March, it has been testing the technology needed to detect and measure gravitational waves, ripples in space-time, first predicted by Einstein 100 years ago. These ripples pass through matter and produce changes about a millionth of the size of an atom, making them extremely hard to measure. The ground-based detector, LIGO, recently detected these oscillating waves directly for the first time. They had relatively high frequencies of around 100 Hz. Gravitational waves cover a much wider range of frequencies, and a space-based observatory could detect waves with frequencies that are 1 million times smaller.
These signals are very, very tiny indeed, and we've been able to show with these test masses inside the LISA Pathfinder satellite that we would be able to see gravitational waves in the frequency band where we're interested in.
The test masses are two identical 46-centimetre metal cubes in freefall, shielded from all external forces other than gravity. LISA Pathfinder has been able to put these cubes in freefall over 5 times more precisely than required.
I think LISA Pathfinder is already demonstrated that it's possible, actually, to place two test masses in freefall in space with a residual relative acceleration at the level required for the future gravitational wave detector.
LISA Pathfinder confirmed the technology for a space-based gravitational wave detector even before the science operations began. Since then, it has become even more sensitive and closer to the system that will be used on a future gravitational wave detector. This will consist of 3 spacecraft 5 million kilometres apart, each containing cubes in freefall.
So a space-based detector like LISA is looking for low-frequency gravitational waves. And by low frequency, really we're talking about very big objects which are in motion. So we're looking at the centres of galaxies, the supermassive black holes at the centre of a galaxy, and when 2 galaxies merge, the 2 black holes eventually form one big entity. And it's in that merging of the 2 black holes is what we're picking up through LISA.
Gravitational waves will transform astronomy and provide a new way to examine our universe. And now LISA Pathfinder has successfully shown the first step forward to a way to detect low-frequency gravitational waves in space.